In this example we have two ice skaters, Daniel with mass 65 kilograms and Rebecca with mass 45 kilograms, are practicing. Daniel stops to tie his shoelace and, while at rest, is struck by Rebecca, who is moving at 13 meters per second before she collides with him. After the collision, Rebecca has a velocity of magnitude 8 meters per second at an angle of 53.1 degrees from her initial direction. Both skaters move on the frictionless horizontal surface of the rink. For letter A, what are the magnitude and direction of Daniel's velocity after the collision? For letter B, what is the change in total kinetic energy of the skaters as a result of the collision? First we draw the problem and identify the quantities. We see here that the problem is as an example of collision in two-dimensional motion. We note that the angle after collision mass 1 or moves in the first quarter, and we assume that the direction of second mass would be sensible, it moves on the fourth quarter, and so it is assumed that mass 2 vertical component is negative. We then write the equations along the two axes. For the x-axis, we see that it can be simplified after substitution. We turn it into equation A. Similarly, we do the same for the y direction and simplify it to equation B. The third step is to use the ideal equations to solve for letter A. We do this by using equations obtained earlier and rewriting the first equation, and obtain an expression for the velocity for the second mass post-collision as equation A prime. We then rewrite equation B and write it as an expression for theta prime for the second mass. We then substitute equation A prime to B prime and solve for the position of the mass 2 after collision, which is equal to 30 degrees with respect to the horizontal. Then this angle is used and substituted to a prime, and we get the magnitude of the velocity of second mass, which is 7.2 meters per second. Note that we can substitute theta prime to equation B prime also and obtain the same value of the magnitude of the velocity of the second mass. For letter B, we are to find the total kinetic energy of the skaters as a result of the collision. We take the difference of the kinetic energy after minus kinetic energy total to determine this value. We see that the change of total kinetic energy is equal to the negative of 678 joules.